Hello again. This is Math 1220 coming to you from the College of DuPage, and the title of this lecture is Fuzzy Logic. This is our 6th lecture in the series on logic. As always, please be an attentive learner as you watch this video. Let's first talk about fuzzy statements. Mathematicians developed fuzzy logic in order to apply the techniques of logic more widely. This is a perfectly acceptable and well-developed area of mathematics. Once we define the meaning of fuzzy statements and explain how fuzzy connectives behave, like conjunction, disjunction, implication, if-then, so on and so forth, we can work with them as we did for other non-fuzzy or crisp statements. So here is a definition. In fuzzy logic, a statement is a declarative sentence that has an associated truth value between 0 and 1 inclusive. So it can be 0, it can be 1, and it can be anything in between. So here are some example statements in fuzzy logic. I like NASCAR racing. And we're going to say, suppose that has a truth value of 0.7. That's saying the degree to which you like NASCAR racing is 70%. Tiger Woods is a great golfer. The degree to which you feel that is true is 92%. Maine is a large state. The degree to which you feel that's true is 45%. Gone with the Wind is a great movie, and the degree to which you feel that that is true is 73%. You find mathematics interesting, and you say that the degree to which you agree with that is 70%. So you see we're assigning values between 0 and 1 inclusive in fuzzy logic. We're now going to expand our idea of fuzzy statements, where we have a declarative statement and then a value between 0 and 1 inclusive associated with it, to fuzzy connectives. So we're going to consider how connectives work in fuzzy logic. And so what we're going to first define is what is the negation of a statement P. So if P is a statement in fuzzy logic, then the truth value of the negation of P, written negation P like this, is 1 minus the truth value of P. Let's do a calculation with this. So in part A, we said that Tiger Woods is a great golfer, had a truth value of 0.92. So that means that Tiger Woods is not a great golfer, has a truth value of 1 minus 0.92 or 0.08. In the first example, we said that Maine is a large state, had a truth value of 45%. So Maine is not a large state. The negation of that has a truth value of 1 minus 45% is equal to 55%. So we've defined what it means to do a negation in fuzzy logic. It's also easy to define and then compute conjunctions and disjunctions in fuzzy logic. So suppose that P and Q are two statements in fuzzy logic. The truth value of the disjunction of P and Q, written P or Q, and again the symbolism is something you want to know about, is the maximum of the truth values for P and Q. So it's the maximum of those. The truth value of the conjunction of P and Q, written P and Q, is the minimum of the truth value for P and Q. And when you think about this being or and this being and, that's very consistent with what you would expect it to be. So now we're going to do an example of calculating disjunction and conjunctions in fuzzy logic. Okay, so we're going to let I be the statement, inflation is driving up the cost of a college education, and G represent less government funding is driving up the cost of a college education. Now let's assume that I has a truth value of 65%. and that G has a truth value of 73%. Then if we say inflation and, that's the conjunction, less government funding are driving up the cost of an education. That and is telling us we're going to be using the minimum. If we say inflation or less government funding is driving up the cost of an education, that is an or, the key word, so that is going to be the maximum of those truth values. And so for part A, it was going to be the minimum of 0.65 and 0.73, which is 0.65. And in B, it was the maximum, and so we're taking 0.65 and 0.73. The maximum of those two is 0.73. So let's do a more complex statement. So we're having three truth values here. This is H, S, and C. H is defined to be foreign cars have high resale value, and that was 0.85. That means the degree to which you agree to that statement is 0.85. Foreign cars are safer than domestic cars, and the truth value of that is 0.73. That's the degree to which you agree with that statement. And foreign cars cost more than domestic cars, and the degree to which you agree with that is 0.6. So you want to find the truth value of this statement. Foreign cars have high resale value, but it is not true that they are safer or cost more than domestic cars. So what we're going to do is we're going to translate this statement into this statement, and recall that but is and it's not true. So this translates into, this word statement translates into H and negation parentheses S or C. And we have the truth values associated with that. So now what we're going to do is we start inside these parentheses, and we're going to take the maximum of 0.73 and 0.6, and that is going to be 0.73. So this is 0.73. Then we're going to do the negation. Now the negation of 0.73 is 1 minus 0.73, which is 0.27. Now we have H, which is 0.85, and 0.27, and we're going to take the minimum of those because it's a conjunction, and the minimum is 0.27. Make sure you can do calculations of this kind. It is also easy to use truth tables to prove that this conditional, if P, then Q, is logically equivalent to negation P or Q. So that's one way we can change this into a logical statement. So that means that what we can do is we can also use fuzzy logic for this using that logical equivalent. So if P and Q are two statements in fuzzy logic, then the truth value of the conditional, if P, then Q, is defined to be the truth value of negation P or Q. So let P, here's an example of computing the truth values of conditionals. Let P have a truth value of 0.75 and Q have a truth value of 0.46. Find the truth value of if P, then Q. Well, we're going to look at negation P or Q. So that's going to be the negation of the 0.75, which is going to be 0.25. Then it's 0.25 or 0.46, which is going to be 0.46. Q implies P is going to be negation Q or P. So that's the negation of the 46, which is going to be 54, or 75, and this is going to be the maximum of the two. So that is going to be 0.75. And the last one, this is negation Q implies negation P. Now one way to deal with this is we actually know that the statement C was logically equivalent to if P then Q by previous things we did, so it should have the same truth value. And here it's saying that should not surprise you that that has the same truth value, and that's because these two statements were proven to be logically equivalent. That's because the contrapositive has the same truth value as the initial conditional. But here we just do the calculation, so we do the so we're going to do negation of the negation of Q, but that's just Q. And the negation of P is going to be 0.75, the negation of 0.75, and that's going to be 0.25. So what we're looking at then is 0.46 or 0.25, and that's 0.46. Again, the same answer as A. Let's look at one final example where we actually use this in decision making. So suppose you were trying to decide to either repair your car, buy a newer used car, or buy a new car. And you were interested in cost, reliability, the size, good gas mileage, and safety. So those were your considerations that you were having. But those considerations were not equally important to you. And in fact, the importance were this was 70%, that was 60%, that was 45, that is 65, and that is 75. So you see, you can use this in decision making, and what we're going to do is we want to look at the statement. The statement, this is importance, so not important, or C. And C is the repair cost for each. So you see, this is you want to be your criterion. So we can do fuzzy logic on each of these for the options. We can look at fuzzy logic for repair, used, or new. And we're looking at this, this, and this. Now, since all of these are important but of different matters, then what you can do is you can take the conjunction of all these. Now, the conjunction of all these is going to be the minimum, so that's 40, that's 60, and that's 30. But then you take the maximum of that conjunction, and so in this case, you would decide to buy a used car. Think about this example, please. In closing, now more than ever, time is precious. Each day must count. Do the math. It will make you strong. And now more than ever, take care of yourself and of each other. May God bless you all.